Angle identities say? The half-angle identities say the following, and they're on the board too. If you have an angle, and you'd like to divide that angle by 2, and you'd like to know what the cosine of the result of division by 2 is, here's a formula. It's plus or minus, maybe I'll point to the board too, the square root of 1 plus the cosine of the angle before you divide it by 2, and then divide that by 2. If you want the sine of half an angle, it's very similar, but with a minus instead of a plus. If you want the tangent of half an angle, well, there's no plus or minus ambiguity. And you can write it down as 1 minus the sine of that angle divided by the cosine of that angle. So, there are the formulas that I want to use today. Let's talk about how to use them. Yeah?
On paper, it's cosine over sine. Does that matter?
Oh, yeah, it does. And that's what's on the board is, well, you know what? Let's do the following to check. So I just thought that one of those two is correct. So if, say, you want to encounter a multiple choice problem on the exam that says which of the following is equal to the tangent of a over 2, and these were the two options, what's some stuff you could do? Put it into a calculator. In fact, let's put it into a graphing calculator. Let's look at some graphs. Whichever one of these is actually correct should have the exact same graph as the tangent of x over 2. So, you'll pull out the graphing machine you like to use. I'll pull up the graphing machine I want to use. There's the graph of the tangent of x divided by 2. Here's this thing on the board. 1 minus sine of x divided by cosine of x. Does that look the same? Does it look somehow related, though? Yeah, so, this isn't right, but I bet this is some shift of cotangent or something. Maybe it's cotangent on the nose. Let's also graph the one that's written down. Parentheses 1 minus cosine of x divided by sine of x. So that one's gone. Popple and Hyde now look like they line up pretty good. Does that agree with people who went and graphed these things using their own calculators? Nice. So, well, now I forget. Was the thing on the paper right or the thing on the board right? Paper right. And to some extent, so one thing you might be able to infer from the fact that that one was fought up from the front of my mind, how much emphasis I'm going to put on the half-angle formula for tangent. Again, it's important to note that the half-angle formulas exist. There are going to be plenty of times when you'll want to think about things like tangent at an angle divided by 2. There's what you can use to simplify a computation involving it. And as long as you know that that formula exists, you can look it up when you need it. So, with those on the board, I guess you can't do that on the exam. So how many people are maybe thinking of putting those maybe on some sort of note sheet for the midterm and then the final? Yeah. And especially for this midterm, if you haven't just been making 2 copies of your note card for the midterm, you might want to consider doing that anyway because you'll need to look at something for the final. Yeah.
Semi-stupid question. When is the midterm?
Sounds like it's on Wednesday.
It's great.
Scroll down. Midterm period is that Wednesday. I guess we could move it up to Monday, depending on how people feel, whether they'd like more time after the midterm for the final, more time before the midterm. Like it where it is? Okay, then we'll leave it where it is. Cool. All right, so let's talk about how to use the half-angle identities. And let's use them first to do something that we assorted as truth at some point in the past, without any justification, let's get this result. So there are a few times when, like, I've just said cosine of pi over 8 is equal to this. Any people just remember what that was? Yeah, it was kind of complicated. There were a bunch of 2's in it and the square root, I think. Maybe 2 square roots. Let's try to figure out what it is using the half-angle identity. Do you have it? No, okay, not a have it. Nice. Let's do it. So if I want to compute the cosine of pi over 8, is pi over 8 half of an angle that we understand? Yeah. What would you want to divide by 2 to get pi over 8? Pi over 4. So let's use the half-angle identity, where this will have the role of A. Or if you're looking at the previous page, I think I called the variable theta instead. Doesn't matter what you call the variable. Let's use the half-angle identity with that as A. So let's just write down what it is. So this will be plus or minus the square root of 1 plus the cosine of pi over 4, close parentheses, over 2. All right. So what are the things we need to prioritize? I think we should think about that plus or minus. We know what cosine of pi over 4 is, so we're going to replace that with the thing that we know that it's equal to. And then I guess we want to like simplify or something. So first let's deal with the plus or minus. And to do that, let's think about pi over 8. What quadrant does pi over 8 sit in?
1.
Quadrant 1. Right, it's like a really little angle. It's right there. So it's in quadrant 1. So is cosine positive or negative? All right. So that's something you always have to do whenever you're trying to use the half-angle identity to do something. You need to just think independently about whether the result will be positive or negative. And maybe before we even continue here, let's think about what would happen on cosine of 9 pi over 8. Again, 9 pi over 8 is half of an angle that we understand. So we can use the half-angle formula again. This will be plus or minus the square root of 1 plus the cosine 9 pi over 4 over 2. And let's go through the same set of thoughts first. 9 pi over 8. Draw that angle. What quadrant is it in? Let's maybe see a show of hands. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Didn't raise your hand for any other option. Okay, cool. It is in a quadrant. So let's figure out which one by thinking about how big it is. Is 9 pi over 8 between 0 and pi over 2? No, because pi over 2 is how many pi's over 8? 4 pi over 8? So let's think of that pi over 2 as 4 pi over 8. 9 pi over 8 is not going to be between those two. There's an angle of pi. What would pi be if you wrote it with an 8 in the denominator? 8 pi over 8. Is 9 pi over 8 in between 4 pi over 8 and 8 pi over 8? Nice, but we're almost at 9 pi over 8, right? We just need to go a little bit farther. What quadrant is that in? Quadrant 3. Is cosine positive or negative? So that picture tells me that the cosine of 9 pi over 8 is negative. So let's go back over here. Plus or minus? So whenever you use the half angle identity, you just have to separately think about, is this going to be positive or negative? Cool, so let's go back to the example, the first example now. What's the cosine of pi over 4? Square root 2 over 2. So I can replace this with square root 2 over 2. That'll give me plus the square root of 1 plus square root 2 over 2 all over 2. And at that point, the trigonometry itself is done. But we should probably simplify this answer. And maybe I'll see how people feel about the algebra to simplify. Should I talk through, or should I just pause for a moment? Should I talk through the simplification? All right. So, but what I mean by I is, let's just prompt some ideas together. I see 1 plus a fraction in the numerator of this fraction. How would you simplify 1 plus that fraction? Get a common denominator so that you can add fractions. So to do that, how should you write that 1? 2 over 2. So let's do that. This is the square root of 2 over 2 plus square root of 2 over 2. That 2 doesn't look particularly compelling. All over 2. All right. And the whole reason to get common denominators is so that we can add fractions. What is the numerator of this thing equal to? 2 plus root 2, all that divided by 2. So, big square root, parentheses, 2 plus the square root of 2, divided by 2, and then all that gets divided by 2. Folks feel good so far? What happens if you divide something by 2 and then divide by 2 again? Say that. I think it's another thing. Okay. You divide by 4, right? You divide by 2 and then divide by 2, you're 4ing it? Sorry to call you out. It looked like you just said that, I think. 2 plus root 2 all over 4, and let's keep simplifying. Do you see any perfect square underneath the square root? What perfect square do you see underneath that square root? 4. What's the square root of 4? 2. Pull that out, and hopefully the answer is something that at least looks a little bit familiar. Square root of 2 plus square root of 2. And then I'm emphasizing that the 2 in the bottom is not under the square root anymore by drawing that fraction directly with the line. How's that example feel? So, whenever you want to use the half angle identity, of course you need to write down that half angle identity. Then you need to decide whether you want the result to be positive or negative. And you can't use the half angle identity to do that. You just have to draw the angle you're interested in, figure out what quadrant. Then, hopefully you're using the half angle identity because you know the cosine of the angle before you divide it by 2. So do that. And then go through the simplification. And just to remind you that, if this is a multiple choice problem, do you think you could get a decimal approximation for this using the half angle identity? Yeah, in fact, directly ask your calculator, what is the cosine of pi over 8? What do you get? I'm happy with everything except for the water radian. Radian is something that you would use to modify an angle. Cosine of an angle isn't an angle anymore, so it's just 0.92. I guess it's important that you are in radian mode, though, right? If you were in degree mode, I think you'd get something really close to 1, but like too close to 1. Does that agree with what other people got using the machine? Could you also get a decimal approximation for this? In fact, have you done already? Yeah, do it. You did? Okay. So, using a machine, this is also 0.92. So if this were like a multiple choice question, do you think you could do this without knowing the half angle identity? Yeah. And I'll do a few things to emphasize like calculatory ways to sidestep questions. So I think that's just kind of valuable. Let's also talk a little bit more about cosine of 9 pi over 8. So we got it down to negative the square root of 1 plus the cosine 9 pi over 4 all over 2. What's the cosine of 9 pi over 4? Ideally by looking at the unit circle. Well, I guess 9 pi over 4 isn't literally a thing you see on the unit circle, is it? But things that have pi over 4s involved are. So let's just figure out what that is, where that puts you on the unit circle. So, this picture is useful. So see, there's 0, there's pi over 4, there's 2 pi over 4, right? That's pi over 2. 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, and if you go one more, you're up to 9 over 4. So 9 pi over 4 is coterminal to pi over 4. It gives you the same point on the unit circle. So what's the cosine of 9 pi over 4? Square root 2 over 2. So sometimes you might see angles that are bigger than 2 pi, as long as they're not like too much too big. Just like count up. If they're gigantic, like 5,376 pi over 4, you would have to do some long division and then figure out how much you can throw out. That idea is familiar, I hope. Nice. Okay, cool. So this whole thing will be negative, because you told me it was negative a while ago. The square root of 1 plus cosine of 9 pi over 4 is the square root of 2 over 2 all over 2. Does that now look kind of familiar to the computation we just did? So do you think we have to do it again? What will that work out to be? Yeah. About negative 0.92, because it'll be that. Or if you want the exact thing, I guess it'll be negative what we got exactly. Negative square root 2 plus the square root of 2 all over 2. Cool. So I think the thing I want to prioritize next isn't a thing in the notes at all. Instead, it's a thing in the sample document for the exam. So what we've done an awful lot with like angle addition and double angle formulas is there have been situations where I've said, here's an angle, I'm not going to tell you the angle, but I'm going to tell you like cosine is booth. Tell me some trig function at two times that angle or something. You can do the same thing with half angle identities. So I'm going to jump almost right to the end of this. Let's look at that problem 48, second to last page. So let's suppose I give you an angle. I don't tell you what the angle is. I tell you that cosine is 1/5, and that the angle A, the angle inside of that parentheses, is between 3 pi over 2 and 2 pi. Let's compute. I think I only want to do one of them right now, and I've used the half angle formula for cosine a bunch, so let's do sine. Do I have a half angle formula for sine? Yeah. And either I guess you have to flip around in the notes, or you can look to my left. The half angle formula for sine says that the sine of A over 2 is plus or minus square root of 1 minus cosine of A all over 2. Feel good right now? So we have the same two priorities that we want to do first. Do we already know what the cosine of A is? Yeah. What is the cosine of A in this problem? 1/5. So let's actually do that. Let's leave the plus or minus as ambiguous for now. Plus or minus the square root of 1 minus 1 over 5 over 2. So there's like some algebra to do to simplify it. Let's deal with the plus or minus sign before we get much farther. So to figure out whether it's plus or minus, I need to know what quadrant A over 2 sits in. Is there enough information in this problem to see where A over 2 lives? What quadrant does A over 2 live in? No. So, tell me why fall. Yes, and by the thing you mean A. That's not A over 2. I need to know what A over 2 lives between. So, but let's figure that out. So you know that 3 pi over 2 is less than A is less than pi, 2 pi. I need to know where A over 2 lives. So, given the inequality written right above, how would you figure out something about A over 2? Not even cosine inverse. I just need to replace a number A with that number divided by 2. So you can divide everything in that inequality by 2. So, what's 2 pi when you divide it by 2? What's 3 pi over 2 when you divide it by 2? All right, so there's the thing we actually know about A over 2. What quadrant does A over 2 live in? Let's draw them out. Where does 3 pi over 4 live? Quadrant 2. 3 pi over 4 is in fact like halfway through a quadrant 2. Where does an angle of pi live? Yeah. Well, kind of. It's like at the threshold between quadrant 2 and quadrant 3. So A over 2 lives between those two. A over 2 is somewhere in there. So now I'll ask you again, what quadrant does A over 2 live in? Quadrant 2. So this divide by 2 step, there is a subtlety there. You need to do some more to figure out what quadrant A over 2 lives in, not what quadrant A lives in. All right, so given that, do I want the option that's plus or the option that's minus? Minus. Cosine, well, wait, do I want cosine or sine right now? Sine. So plus. Because I want sine of A over 2. I mean, quadrant 2, sine is positive. All right. Does that now look like something that we could easily enough simplify? Should I talk through the simplification? Cool, let's do it. In the numerator, I see 1 minus 1/5. What's 1 minus 1/5? 4/5. If I have all of the thing, take away a fifth of the thing, I have 4/5 of the thing left. What's 4/5 divided by 2? 2/5. So that was fast, but now I know everything under that square root. Equals plus. You don't need to say the plus, but I will. Plus 2 over 5. Is there any more simplification that might be useful? I see like a fraction under the square root, so I wouldn't really see a square root in the denominator. So I'm pretty happy with this answer. Let's rewrite it this way. Root 2 over root 5. Is there a square root in the denominator? How do you make there not be a square root in the denominator? Multiply and divide by that square root. So it'll be the square root of 2 times 5, also known as 10, divided by 5. How do people feel about that idea? Nice. So I promised that I'd say a few things about how you can bypass some of these problems by thinking in a different way and using a calculator. Let's go through and see how to answer exactly this question without using the half-angle identity. Maybe you've forgotten it or you just don't feel comfortable with it. Or you want to do something to double check by using a machine. So, the same thing. So you know that I'm going to write down the same problem again. Cosine of A is 1/5, and 3 pi over 2 is less than A is less than 2 pi. I would like to know the cosine of A over 2. To do that, let's figure out what A is. Because we can. How many angles are there in this range that have cosine equal to 1/5? Just one. And in fact, we can write down the name of that thing by using inverse trigonometry. That seem sensible right now? Let's try to write down exactly this angle. And so I don't know, let's start with this. Cosine of A is 1/5. The graph of cosine is something that you should just know. It looks something like this. I would like the solution that sits between 3 pi over 2 and 2 pi. So I want that solution. People feel all right now? So here's an answer that's the obvious choice for A that isn't right. What if you want to write A is equal to the inverse cosine of 1/5? That's not right, but why isn't it right? Yeah, it'd be in the wrong quadrant. This answer is cosine inverse of 1/5. All right, so the unit circle version is there's inverse cosine of 1/5. It looks like I want the one that's in quadrant 4. So how do you describe the one of these that is in quadrant 4? 2 pi minus. It still needs to be positive, so I don't want to just use negative that angle. I'll use 2 pi minus. So A, really it's equal to 2 pi minus cosine inverse of 1/5. Oh, neat. So now I know exactly what A is. That means I can write down cosine of A. Cosine of A over 2. Cosine of A over 2 will be cosine of 2 pi minus cosine inverse of 1/5 all over 2. And how many people have calculators that have trig functions and inverse trig functions built in? Is that something you could just ask a calculator to approximate? Cool. Yeah, do it, I guess. What is that? What does the calculator say? So let's compute cosine of, I want to divide something by 2. I know that it's slightly unfair, right? I have a proper keyboard interface and I'm stuck using the clunky check calculator interface. And I really dislike,
I really dislike the fact that on things like exams you used like the handheld calculator, which is a toy that you'll never use outside of the context of a math class. If you actually wanted to do like a computation, you won't bust out your TI calculator in the future. You'll use a proper tool like Maple or MATLAB or Wolfram Alpha even. But yeah, let's do. So I'm going to type that into the calculator. Sorry, I moved it off the screen. Cosine of 2 times pi minus cosine inverse, arc cosine of 1 over 5, and then all of that gets divided by 2. It looks like I get negative 0.77-ish. Does that agree with what you get? Oh, wait. Oh, I'm an absolute idiot. Was I supposed to be doing cosine or sine? Sine is the one that I did on the previous page, right? Well, happily, that's easy enough to fix, right? How would you change this to get sine? Replace the cosine with the sine, right? I actually wanted sine of A over 2. Pi minus cosine inverse of 1 over 5, close parentheses, all that divided by 2, close parentheses. 0.63-ish. And in a perfect world, that agrees with the exact value we got on the previous. Square root of 2/5, is that about 0.63-ish? Does this mean yes? Okay, I hear some actual yeses. Cool. So if you want to bypass using the half-angle identity, you can. If you have access to a calculator, you can you can figure out using your brain and inverse trigonometry what the angle A is, what the angle you want to plug into this thing is. Then you have a calculator, plug that angle into the calculator. It'll give you a decimal approximation. If it's a multiple choice problem, well, you can get decimal approximations to all the candidates. Cool. So, with that, I think I'm going to stop. I think I've covered the content I want to cover. I'm going to hand out now these bubble sheets, which you absolutely cannot start filling in yet. You cannot fill these in while I'm in the room, because I'm not allowed to, know what you're writing for obvious reasons. This is an honest thing. So I'll get these handed back. And I have some instructions to read. I have some instructions to read. There it is. Student evaluations are required each semester for all instructions. Evaluations are reviewed annually and are an important tool for professional development. Please give honest and constructive feedback. Please put your instructor's name, that's me, section number, you are section 002, and date, which is still May 3, I think. On the top of the page, I think there's a spot for it. Use a number 2 lead pencil to mark the front. Does anyone need? Okay, good. Do not circle your answers. Make sure to fill in the corresponding bubble for each question. The form does have 2 sides. Make sure to complete the front and back of the form for a complete evaluation. Note that the questions do not line up correctly with the corresponding number, so be sure to fill in your spots on the correct line. This form is to be completed anonymously, and that's why you should not be filling out the form yet. If you are, I'm just avoiding eye contact. Please fill in the circle on the sheet for the answer that best describes your experience to each statement. Once you have it done, bring them up and put them in this manila envelope. And then Madeline, you'll bring them up to the 5th floor. All right. So again, this is where it gets really awkward, because you're not allowed to start filling them in yet, because I'm still in the room, but I need to take these things with me. Everyone get one of the bubble sheets? Okay, cool. keep my coffee cup sealed.